All right, let's do this. This is number 2 for the homework number 7, chapter 7. All right, so the polygons below are similar. Okay, one looks like this little cricket, but it's okay. The figure on the left was reduced to create the polygon on the right. What is the scale factor? Okay, so because it started on the right, because it started on the left and it went to the right, so we want to make sure that we utilize the things that will have the sides that have numbers. So for example, we could utilize 4 and 6, right? So the scale factor, all you have to do is write down what is it now, which is 4, and what was it before, which is 6. So scale factor is 4 to 6, or if you reduce this down, which means we're going to divide it by 2, we're going to get a scale factor of 4 divided by 2, which is 2, and 6 divided by 2, which is 3. So our scale factor is 2/3, or 2 to 3 ratio. Now, if we want to find the value of x, we need to start with, again, 4 to 6. So I'm going to write down 4 to 6 ratio. Or even better, you could do 2 to 3. Actually, let's do a 2 to 3 because we want to make the numbers smaller. So 2 to 3 ratio instead of 4 to 6. So we're going to write 2 to 3 because that's what happens, right? And then what are we going to compare it to? Right? So remember, 2 to 3 is the same as using 4 to 6, except 2 over 3 is just a smaller number. Right? So when we're going to compare x's, then or we're going to find the value of x, then we're going to go ahead and do 6 as the smaller one and x as the bigger one. So we're going to use 6 as the smaller and x as the bigger. Kind of like 2 is smaller than 3. So 6 is smaller than whatever x is. Okay, so you're going to do the math. The math is going to give you 2x equals 18, because all you're doing really is multiplying 2 and x, doing a cross product, and multiplying 3 and 6. Okay, and then when you figure this out, divide it by 2, cross off the 2's, x is going to be 9. We're going to find the value of y. We're going to use the same scale factor, or 4 to 6 if you prefer. I'm going to use 2 to 3 is equal to, and this time around, I'm going to look for y. And the y, notice the y at this time is on the small shape. So we're going to be using y to 12. So it'll be y 12. Okay, and again, same thing. Do cross product. 3 times y is 3y is equal to 2 times 12, which is 24. Divided by 3. Again, the 3's cancel out, or we simplify it down to 1, and we get y is equal to 8. So x is 9, y is 8. Z, again, we're going to use the same scale factor, 2 to 3. Okay, let's look at where z is. I'll use green this time. So z is the top one, so it'll be z over the top, which is 5.7. So z over 5.7. Something's going on here. Z over 5.7. Okay, you're going to go ahead and do cross product. So 3z equals, and 2 times 5.7. So 2 times 5 is 10. And 2 times 0.7 is 1.4. So you get a total of 11.4. Okay, you can use a calculator if you like, but that's how I'm going to do it. So 2 times 5.7 is 11.4. Okay, now you're going to do the same thing. You're going to divide by 3. And cross out 3, and 11.4 divided by 3. You can use your calculator if you like. And get 3.8. Okay, go ahead and pause it and verify. Okay, you check it out. Don't believe me, you need to do it yourself. All right, so backside. The two triangles below are congruent. Write a congruent statement relating the triangles to describe the sequence of transformation that maps one onto the other. Okay, so first this is a two-part. we write a congruent statement. Okay, the congruent statement is basically the triangle name congruent to the other triangle name. So first we'll do, we'll write the congruent statement. So I'm going to start, and you can start anywhere you like. I'm going to start with H goes to A goes to N. Okay, so H, so I'm going to call this one triangle H A N. Han is congruent to triangle, and if I do it, sorry, if I do of H A N in that order, okay, I have to use the same order going the other direction, right? So I'm going to call this one triangle. So since I started with H, I'm going to start with J, and it's going to go to O, and it's going to go to E. Hey, that's Joe. That's my nephew's name, right? So Han is congruent to Joe. All right, so once we got that, now we want to figure out, okay, what sequence of transformation does it take to get one triangle onto the other? Okay, so first of all, you can say, well, let's start with HAN, right? Start with triangle Han. Actually, I'm going to go ahead and draw that out first. I'll put it in red. Okay. Excuse my sloppy line, but we'll just go with that. Okay. I'm going to take that. First, I'm just going to reflect this across the middle line. Okay, so we reflect across this line of symmetry, or the line of reflection. All right, so I'm going to reflect it across this middle line. As soon as my thing loads up, looks like it's taking a little bit of time to load up. So the middle line should be sitting somewhere. Oh, there it is. So I'm going to reflect it across the middle line right here. So when I reflect this, so I'll take this, and I'll reflect it, so I'll flip it left and right. So it's going to reflect across here. That's it. That's all it takes. So one move. So I'll just go with, I'll call this a reflection horizontally across line of reflection. Okay. Another move you can do is you can reflect it. You can reflect it amongst itself. Right? So you can do it. So this is probably what you were thinking. So when I reflect it in where itself is, it's gonna look like that. Up there. Okay. And then, so I can write down, so this is my second move I can make. So I can do so that's my first one. So first thing I can do is reflection across the horizontal line of reflection, and that was the middle line. Okay, second thing I can do, reflect, I'll just abbreviate, horizontally on itself, which is where we're sitting at right now. Okay, and then I'm going to take it and I'm going to translate it to the right, meaning move it to the right, and that's where I end up. So if I reflect horizontally on itself, and I'm going to translate right. Okay, so there's two different moves you can make. Okay, solve a system of equation using any method. All right, this one, looking at this one, looks like the 2x's and negative 2x is going to be able to cancel or eliminate, and you're going to go ahead and just combine it straight down by adding. So you're going to get 9y equals 3 divided by 9. Ooh, this is not going to be nice, but y is equal to 3 over 9. Can't divide that. You can call this 1/3. Okay. And take either equation. I'm going to use the top equation and copy it down, except when I get to y, I'm going to use y is 1/3. So I'm going to copy the top equation. Negative 2x plus 3. Oh, there's a y. So instead of y, I'm going to copy it. I'm going to put down 1/3. And that's going to equal 1. Okay. So in here, I'm going to have to work out the 3 times 1/3. You can use a calculator if you want. Or if you remember anything from fractions, you can actually cancel these 3 because they're diagonally, or one on the top, one on the bottom. So you will actually have negative 2x plus 1 equals 1. So we're going to go ahead and subtract 1. It's going to cancel the 1s. So we have negative 2x is going to equal 0. Uh-oh, which is fine. And divided by negative 2. 0 divided by negative 2. The negative divided by negative makes positive, and 2 divided by 2 is 1. So my answer is just x, or positive x, or positive 1x. Okay, so you don't have to write the positive, and you don't have to write the 1 down. So in that case, you just write down x. So positive 1x, which is x, is equal to 0 divided by negative 2, and that's going to be 0 again. So your y is 1/3, your x is 0. Okay. You could check it if you like. I'm not going to check it. Okay, second one, I'm going to look that up and down, and I'm going to say, you know what? If only I had a negative 3 sitting right there, I can cancel the x's, right? Well, you can totally do that. You can multiply the whole top equation by negative 3. And all you have to do is put a parentheses around a top equation and put a negative 3 in the front. So now my top equation is going to be negative 3x. Negative 3 times 2y is going to be minus 6y equals negative 3 times 1 is negative 3. Okay, and then the bottom, I'm not going to do anything, but I'm just going to go ahead and draw my arrow to show that I'm going to move it over. 3x plus 5y equals 8. And I'm going to add that. Okay, by adding, I'm going to end up eliminating the 3 and negative 3x. That's going to give me negative 1y, or just negative y, is equal to 5. And then if I divide or multiply by negative 1, I'm going to get y equals negative 5. That's my y value. Okay. I'm going to use either the top or bottom equation. Looks like I like the top equation in both, in this case, in the last one. So I'm going to copy it down. X plus 2, oh, there's a y, and y is negative 5 equals 1. Okay, we're going to work the 2 and negative 5 together. So you're going to call this one x. 2 and negative 5 is negative 10 equals 1. And go ahead and add 10. Those 10s are going to cancel, and you're going to get x equals 11. So y is negative 5. X is 11. Okay. All right. Check your answers. Put the x and the y in there. All right.